plus 3y equals 6. That's an example of a linear equation in standard form. If I graph this, what does it look like? A line. Linear equations make lines. So if you graph this, you're going to get a line. So what we are going to do is, I want you to take standard form and put it into function form. What does function form mean again? Solve for y. It says it right there. Solve for y. So I'm going to take ax plus by equals c. Solve it for this guy. So I'm underlining him, meaning he's not moving. Who moves first?
AX.
How do I move ax?
Minus AX.
Why minus ax? A lot of people like divide.
So that's getting rid of AX.
Right now, some people, and I noticed this on the test, we're busy dividing here. Why? If you divide by ax first, what else gets divided? This thing and this thing. It's not helping you get y by itself. What is ax minus an ax? So I do it to the other side. So what's left on this side? By equals, now watch what I'm going to do here. Normally you write c minus ax, right?
Yeah.
Look what I'm going to write. What did I do? I just turned it around. Can I do that? Yeah, sure. That one's negative, that one's positive.
Yeah.
All right, now this is my y. I want y by itself, then what? What gets divided by b? What gets divided by b? Thank you. So I'm dividing everything by b. Now remember what these are here. So what am I getting? I'm getting y equals negative a over b x plus c over b. Now a, b, c, b, all those things, these are just taking the place of numbers. So if I have a negative a over b, that's just going to be a number, right? So I'm going to call this negative a over b by another name, just so it's not so complicated looking. I think I'll call it, let me think of something to call negative a over b. No, I'm going to call it m. And here's my x. And then this c over b, right, it's just taking the place of a number divided by a number. I'm just going to use another name. I'm just going to call it lowercase b. So m is this negative a over b. And the small case b is the c over b. And then I get this thing called y equals mx plus b. This is like magic. This should be, if you're like a choir and violins, because this is the most wonderful thing ever. Y equals mx plus b. I always tell everybody, when you first learn this, this is one of those things. It'll be 25 years from now, I'm like, oh yeah, I remember I took algebra. I only remember one thing. Y equals mx plus b. This will be the thing that you remember, because it's such an awesome little thing. Now, m, that sounds familiar. M, that's slope. Yeah, no, it is. No, I don't know. So this is slope. Here's another little confusing fact here. You know what this thing is? This is the y-intercept of the graph. Now, what's a y-intercept again? Yeah, it's where the line, whatever line you have, right, it hits the y-axis. So this thing right here is where it hits the y-axis. If you want to give it a coordinate, it would be 0, 2. So like magic. If you can take something in standard form and you solve it for y so that it looks like y equals mx plus b, right? We'll have a number here, we'll have a number here. Like by magic, here's your slope, and here's the y-intercept of that graph. Just like that.
Wait, then why do you have a Y-intercept of one? Why do you have a Y-intercept of one?
Remember what y-intercept is? A y-intercept occurs when x is 0. So like if you plug a 0 in here, it goes away and your y value is b. So that's your y-intercept. So this is called the slope-intercept form of a line, of a linear equation, because it just hands it to you. Here's the slope, and here's the y-intercept. And this is going to become very handy, and I'll show you why in a minute. So let's look a little bit closer at it. Y equals mx plus b, m is slope, and b is y-intercept. So let's look at some examples. Now, does this fit the pattern of y equals mx plus b, this particular equation?
Yeah.
Fantastic. So is this a line? Yes. These are linear equations. All I did was take standard form and rearrange. It's still a line. What is the slope of that line? What's the slope of the line? 3. It's the coefficient of the x. Remember what a coefficient is? What's a coefficient? What's a coefficient? Yeah, the number that you're multiplying the variable by. That's the slope. And what is the y-intercept of the graph? So what does that mean? We don't know a lot about this yet, but I do know it's going to cross at y equals 4, or y 0, 4, right? And it's got a positive slope of 3. Something like that. But right away I have a really good idea about what the graph looks like, just by finding the slope and the y-intercept. It's kind of cool. Now going over here, does this one look like y equals mx plus b? No. Can I make it look like y equals mx plus b? Yes. How? Right, remember the y's not going to move. Move the 3x to the other side by subtracting it, so that goes to 0. Put the x term first, is negative, and then y is a plus 2. Because 2 is positive. So the signs kind of stick with the terms there when you write it another way. So does it look like y equals mx plus b now? What's the slope of the line? And what is the y-intercept of that line too? So that means if you were to graph it, and I'm tilting there with the slate, there's 2, the y-intercept, it's negative now. Well, I can't do it. Negative slope, all right, that's horrible. But I know there's a negative slope, a negative line going through 2 on the y-axis. Okay, is this in y equals mx plus b form? So let's solve for y to put it in that form. What do I do first? Subtract 3x to move that term to the other side. So this will be gone. What's left? Negative 3y equals. Now, leave with the x term there. Negative 3x plus 12. 12 is positive. What am I dividing by? And who gets divided by it? Everything. You didn't hear that very loud. So let's see. That becomes 1y. Exactly what we want. Negative 3 over negative 3 is also 1. And there's 1x. How do I write 1x in simplest form? I just write x. And then I've got a 12. Positive 12 divided by negative 3. What's my slope? 0. 1. Because remember that 1 I took away? You can put it back. What's y equals mx plus b? M is 1. What about the y-intercept? Why is it negative 4? I thought it had to be a plus here. What happened? So think of this as y equals 1x plus a negative 4. Is that equivalent to this? What's a positive times a negative? A negative. So y equals x minus 4 is the simplified form of that line. I can put it back unsimplified. Here's my m, and here's my b. It's negative 4. So be careful with the negative sign. Don't forget that. So again, if I was to graph this little guy, why am I so sideways? All right, b is negative 4. It's down here somewhere. 1 is a positive slope, so I've got some kind of positive line that goes to negative 4. We can get a really good idea of what this line looks like without doing a lot of work, really. If I know the slope, then I know the y-intercept. All right, questions on that? Not so bad. I'm going to skip this bit if we have time. We'll come back to that. I want to talk about graphing. I want to talk about graphing a little bit. We know how to graph. We have 2 methods. Remember the 2 methods? Somebody tell me about the table of values method. How does that method work, Andrew?
You have a table of values and each one being a number.
Right. So if you have an X and Y table, you put in some members of the domain, right? So if it's all real numbers, you just put a few in. And then, like you said, you're going to have some rule. You plug that in for X, you solve it for Y. Then I plot all those points. Right? Table of values method. What's the intercept method? How does that one work? Right. So if I set Y equal to 0 and solve for X, that's an X-intercept. And if I replace the X with 0 and solve for Y, that's the Y-intercept. Plot those 2 points, connect that graph. Right, so those are the 2 things we know. They're still there. You can still use them. They're fabulous methods. You're going going to use it for attribute career, but here is for line. Oh, this is kind of an awesome method. Like, look at all those words. Yeah. So let's find a better way. Okay. So what I'm going to do is we're going to use an example, and then I'm going to put all the words back, and we'll kind of take it one step at a time. So let's see. I've got a graph here, or an equation, linear equation. What form is this? Standard form, ax plus by equals c. Well, that's not so useful for me if I want to be in slope-intercept form. So the first thing you want to do is put it in slope-intercept form. So you take this guy, and I say, well, how do I put it in slope-intercept form?
Minus 2x.
Okay, solve that for y. Add 2x to both sides. Whoops. So y equals, now I want to leave with my x term. So 2x, and that's a plus 3. So am I there? Is that y equals mx plus b?
Yes.
Yep. Okay. What's the slope of the line?
2.
How do we get 2? That's where my m is. Y equals mx plus b. What's my y-intercept?
3.
Well, it's a 3-0.
Okay.
0, 3, if you want to write down the coordinate. But where is that going to go? Because I'm going to plot that. So this is a point on the line that I am graphing. Isn't that where that goes? The y-intercept goes on the y-axis in 3. We're going to go in 2 minutes. Don't worry. Just watch. Yeah. Great. Now it says use the slope to locate a second point on the line. Up and over. All right, now I'm going to take this m. And this is simplest form, and I made a very big deal. Always give me the slope in simplest form. Except now I want my ratio back. So how can I make 2 become a fraction? Put it over 1. Now, why am I doing that? Because I'm remembering that slope is vertical change over horizontal change, right? Isn't that what slope is? So let's see. 2 is a positive number. Is a positive number an up direction or down direction? It's an up direction. And this is a 1. It's a positive 1. Is 1 a positive number going to go in the right or the left? It's going to go to the right. So watch what you do. Everybody with me? This is the big thing. This is the big deal right now. So this, right, we agree, this is a point on the line, right? This y-intercept. So I know to get to my next point, it's a vertical change of 2 and a horizontal change of 1. So I do a vertical change of 2, I go up 2, and I do a horizontal change of 1. Look at that, no point. Look at that. So now if you want, I did count up 2 right 1. And then you can make the line. Now, I like having some more points than this. So let's go back to 2 over 1. What's another way of writing 2 over 1? Well, I would say negative 2 over negative 1. Is that the same as 2?
Yes.
Because a negative divided by a negative is positive. So now this is a vertical change, but now it's negative. That says go down. This is a horizontal change, but now it's negative. It says go left. So what can I do? I can go down to left 1. Down to left 1. And I can do that till I run out of space. Because it's easy. Right? If you were using the table of values method, how much work is it to get that many points? A lot, right? You have to figure out some x's, and then you got to plug them in. And so now that I have them, and this is the fun part with this slate, I've got points. I can connect them. And I'm trying, but I'm missing. So pretend I connected them. Right? You can connect them on yours, right? We're on page 2, right? Everybody's writing this down. Right? So, wow. So I can graph stuff, and I don't have to find any coordinates. Because they hand me my first one. They say, here it is. And then I just use that ratio. Flip it over, and look at that. What do you think? We're reserving judgment. We're reserving judgment because we think there's more to it.
Now you say now here's
Right. So let's just review what we just did here. You take the equation, you solve it for y. You put it in y equals mx plus b form. M is the slope, b is the y-intercept. You graph the y-intercept, and then you look at the slope ratio, and then you make that vertical change and horizontal change to find the next point. And you can repeat that as much as you need to. So let's try another example here. So I've got y equals 3x plus 2. Well, my first step is put it in slope-intercept form. Yeah, you know where we are in the papers here?
Yeah.
So, how do I put this in slope-intercept form?
N equals 3.
Oh, wait. How do I put it into slope-intercept form? That's my question.
You're done.
I'm done. It is, right? It already, so if you see anything with y equals, we're good. All right, with the hand raised, not shouting out. What is the slope of this line going to be? Quick.
3.
3. Tell me how you got that.
Because the formula it's mx plus b to the 3x plus 2.
Awesome. What's the y-intercept with the hand raised? What is it, Andrew?
I believe it's 2.
B equals 2. Again, how do we know that? Because we just matched it up, right? So that is point 0, comma 2. It's a point on the line. So I can go ahead and put that point on there. Okay, so I have my slope, and my slope is 3. Let's turn it into a fraction. Let's put it back into its ratio. Okay, so I've got my ratio 3 to 1. So this is my vertical change, and this is my horizontal change. So am I going to go up 3 or down 3?
Up 2.
Because why?
Positive.
3 is positive, up is the positive direction. Okay, and then 1 is my horizontal. Do I go right or do I go left?
Right.
How come I go right? Because it's positive. So where do I start from?
2.
No. You start from a point on the line. Now I've only got one point on the line, the y-intercept. So I'm going to start from there. So according to my slope, I go up 3, that's my vertical change, and then I go right 1, and that's my horizontal change. Okay? So, but that only gives, I'm off the graph, and I kind of like to see what's going on here. So you can take that 3 over 1, and if you make them both negative, that's still a positive number. So now, if it's a negative 3, which way is that? Is that up or down? And now I'm on the bottom, my horizontal change. It's negative. Do I go right or left?
Right.
So you see how the up and right and the down and left are equivalent. So those opposite directions work. So now I'm going to go down 3 and left 1. Down 3 and left 1. There was an interesting question in another class. They said, well, how many points do I actually have to need to do? What's the answer to that question? How many points do you need to do? 2, right? Need to. Have to.
Yeah.
How many should you do, Clint? What do you think?
As many as you can afford.
I would say as many as you can, right? Because now I've got a lot of points here. Is it hard to find points? Once you kind of get that ratio, is it hard? So putting as many in as you can. This is not going to work so well. I'm doing my best, Not too bad. Connect those points, make the arrow, because your line will be more correct the more points you put in. You don't usually put too many points in because, table of values, a lot of computation involved. Even with the intercept method, there's computation. I don't have to do that anymore. It's easy. I can count boxes. Let's try this example. X plus y equals negative 3. So is x plus y equal negative 3? Is that in slope-intercept form?
No.
Y equals mx plus b. How do I get it there?
Subtract it.
Subtract the x, right? Solve it for y, because I want y equals. So y equals, what did I write here? That should be a negative x. Negative x minus 3. Question for that, please. I always put the x term first, that's down here, and the sign sticks to them. The sign sticks to them. So now looking at this, well, what's my slope? With a hand now, hand raised. What's the slope? Jerry, what's the slope? How'd you get negative 1? Yeah, I got my invisible coefficient in my 1 there. So my slope is negative 1. Show of hands, what is my y-intercept? Claire, what is it? Negative 3. And remember, that's a point on the graph. It's this point. So I can go ahead now and I plot that point on the graph. I know the line's going to go through that point. Oh, you're right. Oh my goodness. Okay. Anything that I can use this slate for. Okay, so 1, 2, 3. You're right, thank you. Now my slope is negative 1. And that says I can't see the ratio. So let me just put the 1 on the bottom so I can see it. Alright, so now let's see. I've got a negative 1 over 1. This is my up-down, right? The numerator. Am I going to go up or am I going to go down?
Down one.
Because it's negative, right? Go down. Now what about the 1? Positive, go to the right. So I start with my point on the line. I only have one point on the line, this intercept. So it says go down 1, go right 1. Go down 1, go right 1. That's nice over here, but I'm missing this whole part of the graph. So remember, we talked about this. Negative 1 over 1, what's an equivalent expression? 1 over negative 1. So now my up, down, which way am I going?
You're going up one and out one.
Up 1, now on my bottom, my horizontal is now negative. So look, I went down and right, up and left is equivalent. So now pick that point, go up and left. Up and left, right, by ones. And I just do as many as I can. Why not? It's easy. I put in as many as I can. I connect them. I'm trying. Trying really hard. No, I think that's not too bad, Alex. How's my line? Good. Here's room for me before he's all over it now. Oh, goes around my side. Before he said, that was pretty good. Now he's like, oh, I can't do this. Oh, well, yeah, there you go. Okay, so one other check that I do after I graph, my slope is what kind of number, positive or negative? What kind of line do you have here? Make that check. You know what's real easy to do with these? To go the wrong way. I don't know if we're right. It happens a lot. It's just a common mistake. So I always check. If this is negative, I better have a negative line.
What if you don't?
That means you made a mistake. You zigged when you should have zagged. Right? You made a mistake. So, like, it's very common to go up and right, make that mistake. That's a common mistake you see.
Well, then put your face.
So what? Well, you don't know it's wrong until you say, oh, wait a second, it's supposed to be negative. Oh, that's a mistake. I better fix it. You know what I'm saying? You know what I mean, even? Check. They should match. Negative line, negative slope. All right, what else we got? We got one more.
Oh, yeah.
All right, so 2x plus 3y equals negative 6. Is that slope intercept form? Okay, so I have to solve this guy for y. What do? Subtract 2x to move that guy to the other side, and I'm left with 3y over here. Negative 2x minus 6. Am I there yet? Nope. I'm almost there, but what do I have to do? And what gets divided by 3? Everything. Right. Okay, so 3 over 3, there's my 1y. I'll put it up here so I can see it. Y equals negative 2/3 x, correct?
Yes.
And negative divided by a positive, 6 over 3, 2. So now, show of hand, what's my slope for this guy? What's my show of hands? Katie, my dear. Ooh, well, then let's talk about it, right? So I wanted to match y equals mx plus b. What's m? There you go, you got it. So there's my slope. My y-intercept. What's my y-intercept? Another quiet person. Oh, I'm looking at you, Sean. What's my y-intercept? Stop looking at me. What's the y-intercept? Okay, let's see. Y equals mx plus b. Y equals mx plus minus 2. There you go. There's my y-intercept. And you can think of that as a coordinate pair. It is a coordinate pair. So we go ahead and we graph that guy. Now this, I like this slope. It's already a fraction. Do I have to put it over 1 or anything crazy like that? No, it's already a fraction. So I put the negative up here. So negative 2, am I going to go up or down 2? Down. How come? Because it's negative. Now what about my left, right? Am I going to go right or left 3? I go right because this is positive. Start at a point on the line. I've only got one point, that y-intercept. I go down 2. I go right 3. And I'm already off the graph. What's an equivalent way of writing negative 2/3? 2 over negative 3. You can move that to that negative. So now my up is 2. Oops. And my right left is a left now. You're going to go left 3. So see how it works opposite? If you're going down and right, you can go up and left. It'll be equivalent. So I am going to go up 2 and left 3. And now I'm going to be out of graph either way. But now I can see what I need to do. Oh, I'm having trouble with this one. Okay, there it is. Connect them. Don't forget your arrows. Are the arrows important? Now, I know it's new, so just being new makes it a little bit hard, but what do you think? I think once you do this a few times, you're going to be like, it's nothing to graph these things. It goes really fast. So this is a really good thing to master. All right, so we want to talk about one more thing about these lines, parallel lines. Do you remember way back when I would give you an equation like this, a self-equation? Remember how we did this? We said 2x, what? We did one like it, right? When did we just do this? Like it, right? So I want the x's on one side, right? So remember what you have to do? Say, well, let me subtract the 2x over. And then, uh-oh. Remember what happens? They both go away. And I'm left with this crazy statement. 4 equals negative 4. What? Does 4 equal negative 4? No. So what is math trying to tell me here about this equation? There's no solution, right? Isn't that what that means? There's no x that you can find that's going to make this work. So let's think a little bit about this. A little bit more. Because now that we know how to graph, I want to do a couple of things. I want to graph this side of the equation. And I want to graph that side of the equation. Whoops. That's y equals 2x minus 4. Let's graph these two things. So what's the slope of this one?
2.
And what's its y-intercept?
4.
4. It's a y. I'm having a little slight trouble here. So what? I'm just doing this one now. Let's graph this line. So my b is 4, right? So I go up here. Now a slope of 2 means what? That's 2 over 1. It's either up to right one or down to left one, right? Aren't those my two choices? So if I go up to, I'm kind of off the graph, so let me go down to left one, down to left one, down to right. Oh, here it is. Okay, I'm going to make this line. It's going to work. Nope. It's kind of. All right, pretend it's nice and straight. There's one of the lines. That's y equals 2x plus 4. That's this side. Now let's do y equals 2x minus 4. My slope is still 2. My y-intercept this time is negative 4. Oh, 2 or 4. Okay, so I go up to the right one, up to the right one, up to the right one.
The next to each other.
Okay, they are. So let's see again. Oh, I wish I could draw this better. I'm sorry. Pretend it's there. Pretend it's there. Now, if these were nice straight lines, what kind of lines do they look like? And here's the hint. Straight lines. When do parallel lines intersect? Never. When you have one of these equations, do you know what the solution is? If you graph two lines and they intersect somewhere, that would be the result. That would be the solution to the equation. You guys know that? So if you get an equation with variables on both sides, if you graph one and you graph the other and they meet somewhere, that's the solution. Where are these two lines meeting? Nowhere. They're parallel. That's why there's no solution. Isn't that kind of cool?
No.
Say yes.
Yeah.
Yes, that's kind of cool. I think it is. Yes.
Since you want to do both sides, I get like where the MX plus 3 is coming from, but I don't know.
Well, I'm just saying, let's graph this function. I'm going to call it function y. Let's graph this function. I'm going to call it y. I could have called it f of x and g of x. Oh, no, don't do that. Don't do that. No. I could have, right? So it's just saying, if you have this graph and you have that graph, what's going on? They never meet, so there's no solution. So it's kind of tying in some of that equation stuff with the lines, which I don't know, I think that's pretty neat. So my conclusion, though, is, how come these lines are parallel? Why are these lines parallel? What's the same about them? Jerry, what's the same about them? Their slopes are the same. What's different about them? The y-intercepts. So if you have the same slope, now think about what slope is, it's tilt. So if you have two lines and you tilt them exactly the same way, does it make sense that they're parallel? It kind of does if you think about it. Now why do the y-intercepts have to be different? What if this one also was a plus 4? Where would that line be? It would be the same line. It would be one line right on top of the other line. So that's not parallel line. So for lines to be parallel, same slope, different y-intercepts. That's what we get. So let's see. Lines with the same slope but different y-intercepts are parallel. So I've got this picture here. Can I tell which lines are parallel? And I don't mean by looking. Well, it looks like maybe we're going to use math to prove it. So I can determine if two lines are parallel by looking at their slopes. And I can see all the y-intercepts are different already, so I just need to know are the slopes the same. Now, can we do it relatively fast? What is the slope of the blue line here? Now, I see 2 points. So let's see, I can go up 1 and right 3. So what's the slope of the blue line? Right up 1, right 3, it's 1/3. Well, let's look at the slope of the blue line here. They've given me 2 points. I go up 2, so that's up 2, and then what? How far over? 1, 2, 3, 4, 5. You can't tell if I'm doing it right, so you check on me. Let's make sure. And now let's look at line C. I go up 2, and then how far right? 1, 2, 3, 4, 5, 6. So the slope is 2, 6. Do I leave it 2, 6? What do I get then? All right, what can I conclude? Do I have any parallel lines?
Yeah.
Which ones?
A and C.
The lines A and C are parallel. Why? How come?
Oh, because
That same slope, and what's different about them?
the
Y-intercept. And you can write parallel. This is how you write 2 lines of parallel. You can say A is parallel to C. See those little, they make like little vertical parallel lines. That's the symbol for parallel. A is parallel to C.
Can you go to it?
No.
I have to figure it out.
Look at this next little point here. You tell me why this is important. Don't draw any conclusions by looking. You must use slope to prove parallel lines. I know you can see that. This is part of being a mathematician. A mathematician doesn't use observation to prove a fact. A mathematician uses other facts to prove a fact. So, yeah, they kind of look at, but how come? Maybe one's off by a milliliter, or a little small little bit. So you have to prove it. Well, I know I can prove it. I have a fact that if the slopes are the same and the y-intercepts are different, they're parallel, and you can't argue it anymore. That's it. That's a fact. You can't say, well, what if you're looking at it funny or something? You can't. This is how math works and why our math universe doesn't fall apart, because we base it on fact as much as we can. All right, so does that make sense?
Yes.
All right, so I got some new tries there.
No.
And what I want you to do is figure out, are the lines parallel? Why or why not? So how are you going to approach this?
We find the answer.
What answer?
The answer to the problem.
How do I know 2 lines are parallel?
Because one is a little bit
Slopes are same. What's different? Y-intercepts are different. So what do the what form do you want these equations to be in?
y equals m for n x for e.
Now remember what this is called? Slope intercept form, because it hands you the slope and it hands you a y-intercept. Slope intercept form. So give these guys a try. If you have questions, let me know. The question I just got was, does it have to be plus b? Yes. But b could be negative, so let's look at an example. Y equals 3x plus, here's a negative b, right? But well, how do I, is the simplest form? No. So what's a positive times a negative? So when something's presented to you this way, it looks like, well, that's minus b. No, it's not. It's plus a negative number. So the b for this one will be negative 2. That was a great question. All right, let's see. Here's what I got. And let me just get this.
Oh, yes, yeah.
I got no.
I got this note.
I got no, yes, no.
All right, so I said the first one, the slopes are different. Well, what's the slope of this one? It's 5, right? How'd I get that? Y equals mx plus bm is 5. Now this one, I had to subtract 5x. So y equals negative 5x plus 7. So what's the slope of the second line? It's negative 5. Are the slopes the same?
I was being so stupid.
Then it can't be parallel. Now what about this one? Here my slope is 3, and my y-intercept is 2. Now this one, all I did was I kind of messed around with you a little bit. I can turn this around, and I can even turn those guys
That's just what
around.
I did, guys.
That's what I did.
M is 3, and B is
Negative
7. My slopes are the same, the y-intercepts are different, parallel lines. These 2 lines are parallel. What's the slope of this one? Is negative half. What's the y-intercept of this one?
None. 0.
0. 0 is not none. Let's see, I'm going to subtract an x. And then what gets divided by 2? What gets divided by 2?
Everything.
Everything. So this one has a slope of negative